Find the open intervals on which the function is increasing or decreasing, given the mystery graph of the function over here. Identify the function's local and absolute extreme values, saying where they occur. So it's just by looking at the graph, we see that there is a local extreme at this -2, and we see that the function is increasing on -2 to 2. So the function was going up from -2 to 2 and here, and decreasing -6 to -2, and also decreasing on 2 to 6. The function is going down from -6 to -2, decreasing. This one was increasing, and then it looks like it's decreasing over here from 2 to 6, coming down. Okay, so that's what we have there. The absolute minimum of the function occurs at -2 right here, and the function value is f of -2 is equal to -4. So the value is minimum, the absolute minimum value of the function is -4, occurring at x equals -2. The absolute max of the function we see up here occurs at x equals 2, and the absolute maximum value looks like it's 4. The local minimum is at x equals -2 down here, and the local min value is f of -2, which we already saw was -4. So this is a case where the absolute minimum value matches up with the local minimum, but they don't have to. And the local max at x equals 2 was a local max here, and the value was 4. And again, the local max happened to match up with the absolute max, but did not need to. Over here we have some more examples that I made up here. Here's a function g. It has no absolute max, and yet you're looking at this point here and you say, well, it maxes out at 2. But because it's an open circle, it never achieves 2. So there is no actual maximum, because if you say that the maximum is 1.9, then 1.91 is higher. You can always find a higher value. It doesn't achieve the maximum, so there is no absolute max. And by the way, absolute max, global, same thing. They mean the same. You'll see them referred to in various books as either global max or min or absolute max or min. G has a local max at x equals 0. That's right here. So there's your level point local max. G has absolute minimum achieved at x equals -1 right there. And the absolute minimum value looks like -2. G of -1 looks like it's about -2. Then we go on for another example. Here's another function h. It has an absolute or global max at x equals -1 right here. It achieves that max value and there is no higher value, so that makes it a global or absolute max. It also has a local max there because around that point close in there are no values higher, so that is indeed also a local max. H has no absolute minimum because although there's a limiting value of -3, it never achieves -3 and it keeps on going down closer and closer to -3 but never gets there. So whatever value you were to name as the absolute min, you'd always be able to find a lower one. And you can't say it's -3 because it never reaches -3. So in that sense there is no absolute minimum.